Question number 3. This will be published on 18th Wednesday, 18th December, Wednesday 2024. Okay. So in future, whoever looks into it, they'll get to know which date was published. Okay, fine. Now let us start with this. This question is for 11 marks, a problem on gravitation. Let me start the timer. Explain what is meant by the gravitational potential of the surface of a planet. What do you mean by gravitational potential? Gravitational potential is nothing but, see, first thing is, this is for 2 marks. So you write potential V is equal to work done divided by mass. Okay, if it was electricity, it's divided by charge. It's a gravitation divided by mass. But this will not be sufficient. So you need to write it in statement because it's asking you explain. So what you should do is, you should say work done in bringing a unit mass from infinity to a point on the surface of the planet. Why do I need to put this one? Because there's already been a context over here. Gravitational potential on this surface of a planet. So therefore, this whole thing should be written over here. From infinity to a point, you are bringing this. This will give you 2 marks. At the same time, if in addition to it, if you want to write, you can write V is equal to W by M, and you can say the unit of it is in volts. I do not know whether how many of you know that the unit of potential is always volt. It can either be a gravitational potential, magnetic potential, electric potential. Always potential or potential differences are measured in terms of volts. Like for example, energy, you say gravitational energy, mechanical energy, electrical energy, any type of energy is always measured in joules. Okay, so here also the same one. Right, now let us move on to the next question. An unpowered projectile is fired vertically upwards up into deep space from the surface of a planet Venus. Okay, so this is the planet Venus, and then you are now firing a projectile vertically upwards like this. Okay, assuming that the gravitational effects of the sun and other planets are negligible, the following data is given. Mass of the Venus, capital M, is given to you. Radius of it is given to you. Mass of the projectile is given to you. Initial speed of the projectile V is given to you, but it is said that 1.1 times escape speed. See, if it is projected at escape speed, it will not come back to the planet. If it is projected at more than escape speed, definitely it will keep on moving, and then it will escape from the surface of the planet, from the gravitational pull of the planet. Okay, so that is one thing known. Determine the initial kinetic energy of the projectile. Kinetic energy, what is so special? Half mv square. That's what you need to find, which I will write this as half into, what's the value of m? M is the mass of projectile, which is 3.5 into 10 cube multiplied by v square. What is v here? See, v, it says 1.1 times escape speed. What is escape speed given by? Escape velocity is given by square root of 2gm divided by r, right? Where m is the mass of the planet, r is the radius of the planet. We need to substitute this. So therefore, here it becomes v escape 1.1 square. I'll write this as 1.1 v escape square. I'll write like this over here, which once again I can write this as half into 3.5 into 10 cube into 1.1 square multiplied by v escape square. What is v escape square? V escape square is equal to 2gm divided by r. This root goes away, so I write this as 2gm by r, right? And then next what I will do is, I will substitute all the values over here. So which I will write it here because I need some space. I write kinetic energy equal to, and I write half into 3.5 multiplied by 10 cube into 1.1 square is 1.21 multiplied by 2 multiplied by g. What is g? 6.67 into 10 to the power of minus 11 multiplied by mass. Which mass is this? Mass of Venus, which is 4.87 into 10 to the power of 24 divided by r. Where is r? Where do I write here? I'll write here by r. What is r here? Radius of it 6.05 into 10 power 6. 6.05 into 10 to the power of 6. So I have taken all of them. Now let me calculate it. Where is my calculator? I have to get a calculator. It's here, right? Okay, so let me calculate this. So this should now be 3.5 divided by 2 equal to so much multiplied by 1.21 multiplied by, I have the text hidden here, We have done until here. Until here we have done. Multiplied by 2, multiplied by 6.67, multiplied by 4.87 is equal to so much, divided by 6.05. I get the answers 22.73. I have just taken only the values, that is the numbers, the decimals and all those, not the powers. So what is the answer I get? I get 22.73. 22.73 multiplied by 10 to the power of, here you have 3, here you have minus 11, 3 minus 1 should be minus 8, minus 8 plus 24 should be 16, 16 minus 6 should be 10, 10. What is the unit? Kinetic energy, joules. In other words, I can now write this as 2.27 into 10 to the power of 11 joules. Okay, this is the answer. So you have 3 significant figures. I kept it in 3 significant figures, right? Now let us move on to the next one. Describe the subsequent motion of the projectile until it is effectively beyond the gravitational field of Venus. What is happening to the motion of the projectile? Now, what happens is for 3 marks. Okay, let me elaborate this. So towards it, when the particle, when the projectile, I'll write down, when the projectile is within the range of gravitational field of Venus, what happens? Gravity is pulling it up, pulling it down, but it already has an energy. The energy keeps on reducing. Kinetic energy gets converted into potential energy. So might be, you can say, since it's asking about the motion of the projectile, so don't mention in terms of energy, mention in terms of speed. Speed decreases or it gets decelerated. So what have you mentioned? Only when it is within the range of gravitational field. Okay, beyond the gravitational field, what happens? There's nothing to pull it back, nothing to force it also, right? Beyond the gravitational field, what happens? It will start moving with uniform velocity. The projectile moves with uniform or constant speed. Okay, so we are done with this, right? So this will give you 3 marks. Then next question. A planet orbits around the sun in a circular orbit with orbital period t and orbital radius r. The mass of the sun is m. So show that this, what is this actually? It's nothing but Kepler's second law. Okay, how do we do this? So very simple. So what you do is, first is take the value of g, which is equal to v naught square divided by r, orbital velocity square divided by r. Okay, and this should also be equal to gm divided by r square. So towards it, this r and this r goes away. So we can take this. Now we already know that orbital velocity is equal to total distance the satellite covers in one time period divided by time period, 2 pi r by t. Substitute this over here. So when I substitute, what will happen? This becomes 4 pi square r square divided by t square. I have substituted for v naught. Okay, this value of v naught I am substituting it here. Okay, is equal to gm divided by r. Now shuffle the terms. Take t square on the subject, which means I will write 4 pi square r cube is equal to gm t square. Push this one downwards, then in that case t square now becomes 4 pi square r cube divided by gm. In other words, t will now become square root of 4 pi square r cube divided by gm. So which is as required here, right? So this will give you 2 marks. This is nothing but derivation of the Kepler's second law, right? Then the Earth's orbit around the sun is almost circular with radius is given. Estimate the mass of the sun. So what should you do? Don't worry about anything. Just look at this formula here. Earth's orbit around the sun is almost circular. So this is what is given. The Earth is here. It goes around the Earth. It goes around the sun. It goes around the sun in how many days? It goes in 365 days. So time period t is already known to you. 365 days. That's the reason why is given you sun and the earth, because that is the one which is easier for us to get to know. Okay, we already live in earth, so we know what is the Earth's time period, right? And radius is also known, which is 1.5 into 10 to the power of 11. Okay, now you see this r is known, t is known, you need to find the value of m. Quite easier. So let us do this. Take m as a subject over here. If I take this, if I square this, what do I get? If I get square this becomes t square is equal to 4 pi square r cube divided by gm. Rm will now be equal to 4 pi square r cube divided by gt square, right? So now this should now be equal to 4 pi square. I don't think, I'll just substitute it. I'll just substitute it as m is equal to 4 into 3.14 3.14 square multiplied by r cube, 1.5 into 10 to the power of 11 whole cube divided by 6.67 10 to the power of minus 11 into t. How do I get the value of t? This is in days. I need to convert it into seconds. So what I will do is, I will write the first value, the value of t over here. First do the calculation for t, and then I will substitute it over here. So value of t is 365 days multiplied by, per day I have 24 hours, per hour I have 60 minutes, per minute I have 60 seconds. If I do all this, I'll get some value that I need to plug in here, right? So let me calculate this value so that we can do it more faster. So now what I will do is, I'll take 365 into 24 into 60 into 60. Okay, so I get 315 36 000. 315 36 000. Let me verify it once again. 315 36 000. I am right. Okay, I'll write down here 315 36 000. And what is it? Is there square here? There is a square here. Square over here. Now let us calculate using our calculator the whole thing. So I have this square we have. So I will do one thing. Take the square of this. Take the square of this. Square of this is equal to, this is so much big. Okay, anyway, multiply this by 6.67. I'll do the denominator first. I get a very big number. I'm not going to write that. Okay, I'm going to keep this in memory, or maybe I'm going to take the reciprocal of this. I take the reciprocal, I get something over here. Okay, in fact, I have not used 10 power minus 11 now. I will keep it aside. So, and then I have 4. This multiplied by 4 is equal to so much. This multiplied by 3.14 star 3.14. So once again I get this much multiplied by, this is 1.5 whole cube, multiplied by 1.5 into 1.5 into 1.5. I get 2. I get the answer as 2 here, multiplied by, wait, I missed something here, into 10 to the power of minus 14. See, e minus 14 is 10 power minus 14. 10 power minus 14 minus 14, and here you have 10 power 11 whole cube. So this will be 10 power 33 divided by, here what do I have, 10 power minus 7. I have not used these powers, right? So I should consider all this. So now what will happen? This will be 2 into 33 minus 14 will be how much? 33 minus 13 is 20. This should be 19. 10 power 10 to the power of 19, and minus 11 comes upwards, it will become plus 11. So this should be 2 into 10 to the power of 30 unit. Mass is measured in kg, so measures kg. Okay, thus the answer is so much over here. I think with this we have come to an end for tomorrow's video. So we will see the rest of the videos in the next class. Okay, thank you.